continue. And I am pleased to invite Bruno DALLA CHIARA. He is full professor in transport systems at the Politecnico di Torino since 2019. He is the coordinator of mobility group of the Italian University Network for Sustainable Development and the mobility manager of the Politecnico di Torino since 2013. He keeps the subjects of rail transport system, urban transit and rope installations, and transport systems and data analytics. Over the years, he has also taught transport systems and external logistics, mobility, transport technology and economics, and sustainable transport systems. He is the author of a number of publications and textbooks on above-mentioned subjects. Today's topic of Bruno DALLA CHIARA speech is the role of sustainable mobility in the future of urban transport, which role for ITC? Dear Bruno, the floor is yours, please.
Thank you very much, Olga. Thank you for inviting me. And good morning, everybody. First of all, I would like to express my closeness to you and my congratulations for organizing this event, notwithstanding the situation. So, my presentation, as it has been introduced, is now, okay, you can see it now, is based on some hypotheses on how our cities can look in the future according to the elements which influence them nowadays and what we expect for the next future. So the role of sustainable mobility in the future, the role of ITS, as Professor Kuniuska already introduced. So let's start from the past, but very shortly. Can you recognize these cities? This was London 1 century ago. This was Paris 1 century ago. This was Milan 1 century ago. This was Turin, the city where I live, a bit more than 1 century ago. And you can recognize these last two pictures. And in 1 century, what has happened? You can look at London, Milan, Paris, and Kiev itself, and Turin after 1 century. And as we have heard in the previous papers, in the previous presentations, road traffic is dominating. Okay, so
dear Bruno, I'm really sorry. I'm sorry for all participants because we have air raid right now and we have a very bad situation regarding the announcing. We need 10 minutes to go to the shelter. I'm really sorry for this, but it's not. Yes, it's our neighbors, unfortunately.
Okay, no problem at all.
10 minutes. We will continue in 10 minutes. Please stay connected. All other participants who are in the safe place now, please stay connected. We will continue in 10 minutes. Thank you. Dear participants, we are mostly here. Do you hear me? Please let me know. А хто продовжує запис? Ага. Ні, це продовжує Наталія Катрушенко. Наталія Катрушенко, ви стали організатором. Ну, продовжуйте, що пора. That's okay. Так. Please let me know, do you hear me? Professor Bruno, do you hear me?
Yes, I hear you.
Oh, that's great. So we are mostly here, mostly all of us. Give 1-2 minutes and we can continue.
Okay. I'm really sorry for that, for you.
Thank you very much. Thank you for these words, but what we can do. Okay, we can start. Yes, dear Bruno, please let's continue. Yeah, thank you.
So I started saying how were our European cities 1 century ago and how do they look like now today? And the main element is as regards transport system is road traffic. But what was the goal 1 century ago and what can be the goal or which can be the goals nowadays? This is the goal of my intervention, and let's discover them together. So 1 century ago, maybe the goal was diffuse motorization. That means guarantee everybody to move for longer travels, for bringing and for carrying goods, and this has been obtained. In 1 century, we have obtained this goal in a regulated and controlled way, though with levels of traffic that are probably higher than we or somebody else expected. Okay, so what influences nowadays our future and what can be our goals for the future in order to pursue them? Well, sustainability is of course one word which is very well recognized, but I want to split it into the contents as regards transport and mobility. So this has been evolving, and these conditioning factors which nowadays influence us can be listed hereafter. The first is the use of land and space. We did not feel that problem 1 century ago, now we do. And the land is the land of infrastructures, for infrastructures, and the land for vehicles within infrastructures. The second is the energy source. 1 century ago, a bit more than 1 century ago, we choose crude oil. All transport modes, nearly all transport modes, except railways, metro systems, and nowadays people movers, rely on crude oil. So the availability of it and the effects of its combustion constitute another element of sustainability. The third is the sensitivity, the attention to the environment that we did not have in the last decades, we have nowadays, both at local level and at global level. The fourth is the fact that by increasing our infrastructures, we need to maintain them and update them from the technological point of view. And this means that we have to sustain them from the economical viewpoint in order to guarantee their maintenance and their upgrading. And then safety. In those pictures that we have seen before, road accidents were not the main problem of our society 1 century ago. Diseases and other problems were the main problems. Nowadays, as we know, road deaths are the first cause of death within our populations in many countries. And last but not least, the relationships. Can we consider the continuing increase of daily mobility as our goal for the future? Or we have a sort of saturation or a decrease? Okay, so this is the list of the elements which influence, in my point of view, our future mobility. So let's see in the urban context how this is, let's say, can be quantified. So in the past, the origin destination matrix was mainly like the one you see here. Home, work, home, school, home, holiday, home, shopping, all done with car. And this matrix is associated to the message that our society has been providing us. If you don't have a car, if you don't use a car, you're a bit out of the society. So this is the message that we have seen so far. And this is represented by a typical origin destination satisfied with cars. But what can we expect for the future? Well, a hierarchical approach where we move from city to city with railways. When we arrive to the node, so the city itself, we can continue with a metro system, with railway systems. We arrive to the smaller node and we can continue by car, by walking, by using bicycle, by using bike sharing, car sharing. So the approach is not origin destination by car or mainly by car, but hierarchical, flexible, and commodal. So these three adjectives will be used by myself later. Hierarchical, flexible, and commodal or plurimodal. And can we quantify this aspect? Yes, we can start doing it from the used space because a private car typically implies 5 square meters per person, twice as much as we refer to the person itself, to the person itself. Then public transport, 4 or 5 passengers per square meter, which is a typical value for the design, engineering and design of public transport, so the use of space on public vehicles. And people movers within these occupy more or less the same amount of surface, and we have to split underneath 8, 9 passengers, 1,000 passengers per hour per direction, or above them. Underneath, we can typically address automated people mover. Above these values, we can address automated metros. I will tell you later why. And then what we have to look at is consider the flexibility of car, because we have to win against that. So if we look at ropeways, typically we have 1.2 meters for the diameter of ground footprint and 10 by 10 square meters for the 3S cable way installation. A bicycle typically implies 0.2 square meters per person. Okay, so what we can understand from this first quantitative slide is that cableways and bicycles can be, let's say, winning in this context. But we have to look also at the energy. A utility car with electric traction, I'm not pushing electric traction, I'm just saying that the most performant in terms of electricity is 0.11, 0.20, 25 kilowatt hours per vehicle kilometer. And railways are around 0.04, 0.09 kilowatt hour per passenger kilometer, even less. We have different sources in literature. Cable-driven installations, so automated people movers with a cable traction, something like 0.027 and even 0.02 if we look at the traction itself. Of course, if we walk and if we go by bike, we don't have this issue. Then, if we consider, so the first was space, the second was what we have just seen, that is the energy used, and the third is the emissions, both at local level and at global level. Let's start with the global level. We know the goals of European Union, but of the world itself, of reduction of CO2. And this goal can be, let's say, pushed through modal shift, of course, technologies, so new powertrains and intelligent transport systems, and through optimization. Well, the transport planning typically operates on the first and second, but even on the third level. And if we look at CO2, what are the variables that we can influence in order to contain them? Well, use for shorter path or don't use at all vehicles, so the space is reduced. This means we can walk instead of using a motor vehicle, and we can approach this hierarchical approach in mobility. Or we can use less internal combustion engine, and this typically, in terms of space, this typically approaches public transport, pooling, or hybridization, as we can see later. Then use less in terms of time, again, the hierarchical approach, commodal, plurimodal approach, and then we can operate directly on the vehicle through its efficiency and reduction of resistances, typically on aerodynamics, speed and acceleration, specific rolling resistance, and mass on dimension of the vehicles. Then there is the driving of the vehicle, the behavior, the driving cycle, and we know that the European Union in the world has agreed on the WLTP in 2017 that is applied, but we need to complete the thought through the well-to-wheel and life cycle analysis. And this is necessary, as we will see later, in order to arrive to a reduction of CO2. So this is the approach that I suggest, that is normally, let's say, shared in a part of scientific literature. That is, okay, electrification, but looking at the well-to-wheel cycle and looking at the life cycle of the vehicle itself. Because if we want to produce an electric vehicle in China, where we have 63 of impact of carbon on the electric grid, of course, the CO2 is produced there. So we don't have to imagine to reduce CO2 while using the electric vehicle if we don't look at the life cycle. So again, this is an important approach that the European Parliament has to conclude, because it has just released the 100% by 2035, but we need to add in the well-to-wheel analysis and in the life cycle. Given that, we need to look at the local emissions too. The local emissions typically are associated to tires, brakes, and the combustion itself. All three contribute as regards the transport domain to local pollution, in particulate matter, NOx, and so on. And if we eliminate at local level, not necessarily for the vehicle themselves, and hybridization can push this goal, because we can have a battery of 8, 10, 12 kilowatt hour, which allows us to cover 50, 60, 80 kilometers with electric traction and leave the freedom of motor vehicles with internal combustion engine by hybridization. Then we will see one day if we go towards fuel cell, but we have time for doing that. What remains is the rolling, and as regards the consumption of the brakes, we need to consider that hybridization itself goes in the direction, because we have the electric motor which allows for the braking instead of having a mechanical one, which is left for the final part of braking. So we have to consider another element that is the very recent release a few days ago of the new European Parliament directive concerning ambient air quality, which makes more constraining the thresholds concerning pollutants that are accepted in cities. And this brings the public administration to intervene when these values are overpassed for a certain number of days in the year. So this means that it will be more, let's say, heavy, more difficult to satisfy this directive, and transport system will be much influenced. My opinion is that we can create some geofenced areas within which, where there is the concentration of pollutants, we can pursue electric traction, but not necessarily with a BEV, battery electric vehicle. Okay, so the emissions at local level are influenced, of course, by modal share, by the composition of the circulating fleet, all the recent Euro 1, Euro 2, Euro 6, and future Euro 7, by the level of vehicle use, and of course, by the let's say, environmental elements which concern the city, so the prevailing ventilation, orography, and the like. But in a modern city, of course, ITS. For what? What for? For knowing that the condition of road use, for influencing traffic lights, for addressing traffic flows, for allowing this plurimodal, comodal, flexible, hierarchical mobility to be satisfied. Okay, and this is a necessary element. So what about safety? We know that in the world, we have 1.35 million road accidents each year, more or less. But half of these deaths are associated to cyclists, motorcyclists, and pedestrians. So we need to take care when we say, well, let's go by bike. we need to guarantee, of course, the infrastructure for these in order to safeguard safety. But there is, let's say, very little literature concerning the passenger fatality rate per passengers per kilometer, or billion passengers per kilometer. UK has released some research dossier documents for many years, then has interrupted. Probably it was too difficult, but anyway, they have strived to do that. And what we can see here that at the top of safety, there are cableways. Automated meters were not analyzed, but they are at the top together with cableways. And then planes, trains, buses, waterborne, van, motor vehicles, bicycle, pedestrian, and motorized two-wheel vehicles. So in the overall sustainability concept, we have to consider space, energy, environment at global and local level, safety, and safety has to balance together with the others to arrive to the final goal. Okay, but we need to consider also another thing, that the users not always are sensible in terms of public interests, and they look at their speed, the availability of the transport system, and this is, for example, the average speed in Turin provided by the 5T ITS system, which monitors traffic in the city. And we can see that it's very competitive because there is an intelligent transport system. But we need to, let's say, moderate this speed in order to favor this integration of the transport modes. Given that the cities have been like this in the last years, how do we expect them on the right side of this graph? So according to what I said so far, how do you expect them on the right side? The future and the actual aims are quality. So we want to travel in being informed without traffic jams and so on. Safety, because we don't want anymore all these deaths on the roads. Security and efficiency in terms of energy and consequent emissions. So this brings to what? Automated people movers and metros, typically automated metros, intelligent transport systems, and data collection for organizing traffic and influencing it, and more all-independent vehicles and green motor, including the sharing mobility, of course. Some cities in Europe, or at least some countries of Europe, require cities to define a sustainable urban mobility plan. Italy has got this rule, this law, as a matter of fact, and European Union is looking at carbon neutrality. That is mission impossible, but at least there is this goal. But again, I repeat, we have to look at the life cycle, because CO2, of course, is a global issue, not national. So what is doing European Union? What is doing Italy in particular, but just because I live here on this side? You know that there are 100 cities which have declared their objective of climate neutrality by 2030. Again, mission impossible, but it's a goal. So we need to pursue that. Turin is within these cities, so we will see in the next 5 years what will be applied to pursue this goal. And of course, this is an element we have to take into account. How can we, let's say, pursue that? MAS, I think all of you know what is the mobility as a service approach. It has not win when public transport is allied together with sharing mobility to win the motor cars, because global mass has declared bankruptcy in April 2024. This is an impossible battle again. They have to collaborate. So the car has to be inserted within the mass approach, but we don't have to push again the origin destination matrix with car, but we leave the car in an interchange area. We continue by train, by metro, by bicycle, walking, and so on. And this is something that MAS, as we know, is pushing much. That is, we have a unique super application, super app, where we can see all the available services, including parking, including, in case, recharging for plug-in hybrid cars or BEV, battery electric vehicles, and public transport in all its, let's say, possibility, including sharing mobility. Italy is applying that, but also many other European countries in this period, 2033, 2026. Turin in particular, but also Rome, for my colleagues, is in, let's say, plenty of application of this in this period. We will see the future, what will bring to, but anyway, it's an instrument. Of course, it has to rely on an efficient supply. So I arrived at the conclusions. I have tried to recover some minutes given the problems that have arisen. So we have to look at urban sustainability as a whole, not just CO2, not just local pollution, not just safety, but energy, pollution, use of space and safety all together with the economical issues. Then we have to pursue a co-modal, that means plurimodal, flexible and hierarchical mobility and transport. We have to monitor mobility for doing that, and ITS are necessary for this, also for informing, of course. We have to apply, and this is something not so treated so far in literature, a geofencing on our areas. We have limited areas, of course, in many cities, limited traffic areas, but we have to look at urban geofencing that is not necessarily with a fencing, but a virtual fencing, and within that, you don't have to provoke local emissions, for example. And last but not least, we integrate them with a bus. So with this, I have concluded. I've tried to provide this overview of my point of view of where we have to address our attention for the future mobility, because we have, like 1 century ago, a moment of changement, and the goal need to be clear in order to pursue them with a shared vision of the future mobility. Thank you very much. I've concluded. Thank you all again, and I'm at disposal for any question.
Thank you, dear Bruno. Thank you a lot for your wonderful and very interesting presentation. So great approach, clear and important understanding. Please question. Yes, Natalia, please switch on the microphone.
First of all, I want to say that we are grateful to you, Bruno, for your so useful and interesting study. And I have a question. As you know, I even can say I afford to say that our country is at the beginning of the usage of intellectual transport systems, speaking about the sustainable mobility. Of course, there are many scientists who works in this field. We have a lot of scientific studies and of course practical usage of it, but still we now deal with developing it and working on usage of intellectual transport systems to provide sustainable mobility. So can you share with the most, as you consider, most important or vulnerable your experience or experience of your country, how to start it and to make it in the nearest future more quickly, more efficient, something like that. Thank you.
Okay. Thank you very much. Your question is very interesting. Well, it requires a certain amount of time, but I try to be synthetic. If you will have shortly, I suppose, I hope, not I suppose, I hope, the possibility to come to visit us, this would be the best condition to say, this is what we did for first, this for second, and so on. Let's start from the definition of intelligent transport system or intellectual transport system. It comes from Latin inter lego. That means I read between the lines, so I understand what is not written, and I connect together. And this connection is already applied from the beginning in railway system because they have a supervision, they have the operation, and they have the driver, which are connected together. And was not so since the beginning in road transport, because the driver can do what he likes or she likes, and the goal of ITS is to connect them. So where we have to start from a supervision room where we can see where the vehicles are. How? Through sensors. Of course, we can use both fixed sensors like inductive loops, magnetometers, video cameras, and so on, and mobile sensors, floating car data, and the like. The sensors allow us to operate at let's say, a central level to provide this intelligence. What do we have to do? To influence traffic lights according to traffic conditions, to give priority to public transport, to tramways, so we need to localize them. I can provide you some examples. In Turin, we have a network like this, fortunately, and you can see that the commercial speed of tramways is something like 20-25 kilometers per hour in week. Well, in the when you don't have rush hours. This means that the effect is visible, but also we have addressing systems towards parking areas in order to allow drivers to use interchange areas where available places are present. So we start from sensors, through supervision systems, through traffic lights, and onboard information. There is a number of applications which regard well, I don't want to enter into much detail. Maybe we can enter into direct contact, so I can provide you some, let's say, examples. But I think this is an important element to arrive to the next steps that I shown before, that is integrating these transport modes in order to facilitate an integrated mobility that the mass mobility as a service is pursuing. Sorry if I've been synthetic, but maybe we can enter into more detail by a direct contact.
Yeah, I think. Yeah, it's a great idea. I think we can connect. I will give Natalia your direct address. Can I ask you also one short question? I don't know. Have you heard Dmitry Bespalov? He had speech today. Oh no, maybe you was not connected at that moment.
I was in the session of discussion of thesis before.
Yes, about transport mobility in Kiev case study, and he said that the cost of not using ITC per 1 day is cost for our city 22 millions. Yes, 22 millions per day. What? Oh, sorry, it's in hryvnias. Sorry, I calculate. It's about 500,000 in euros. So the question is, have you estimated also this cost for not using ITC in European countries? For such example that you provided in your presentation, do you have any information?
Okay, well, they vary a lot according to the level of intelligence that you want to provide at ICT development in general terms. Typically, they are between 5%, 10%, or something more than the cost of the infrastructure. So if you want to pursue a smart road, well, you have 100 for the infrastructure, you have some units per cent, 5, 7, 10, for equipping it with the sensors and information instruments for providing real-time information to drivers or to travelers. Then it's difficult to say this is the value, but of course it depends on the level of development. What I can say is that the development of the infrastructures in many countries, I cannot say in Ukraine because you will have to reconstruct them, but has reached a saturation. We are not pushing an increase of infrastructure apart from where they are necessary, and the completion of the railway network through the TEN-T, Trans-European Network Transport. So what I'm saying is that since we don't need to invest much more on new infrastructures, we need to maintain them. We have to invest on their technological upgrading. And this typically means some units per cent of their realization.
Yes, absolutely agree with you. Thank you.